very much, esteemed Chairman. Good morning. I'd like to extend my kindest regards to all of you and welcome you all. I worked at Sakarya University as a member of academia for 30 years, and starting 2010, I've been working for a private university, the Fatih Sultan Mehmet Vakıf University. It's a university owned by a foundation. I am a metallurgy and material engineer. I worked for the Turkish Water Utilities institution in Istanbul for 7 years. So I will be merging all of these experiences and give you an overview of the historical evolution of the water transmission pipes. In the past, wooden pipes were used. Of course, prior to that, open canals were used for transmission of water. Bamboo was the material of choice, and the world population at the time was 6.5 million people. They made use of materials like wood and bamboo to use it for transmission of water. Then came the use of clay, particularly in Babylon. This was the material of choice for a long period, and we're talking roughly 4,000 years before Christ. And we see some examples similar to the one on the screen, made of clay. Then we come to 3,000 years before Christ, and we see that copper is being used. Of course, copper dates back to 7,000 or 8,000 years before Christ, maybe 10,000 years before Christ. So we see that Egyptians were the first to use copper for water transmission lines. 2,500 before Christ, we see lead being used. It's a very soft material. It's easily shapeable and moldable. So it came into use for transmission of water 2,500 years before Christ. It's also quite anti-corrosion resistant. It has a creep effect. It settles. It's also poisonous. It's toxic. During the Roman times, the Roman Empire, lead pots and pans and utensils were a matter of prestige. And of course that unfortunately meant a shorter lifetime for the people living during the Roman times. After Christ, 300 years after Christ, we see marble being used for water pipes. Certain holes were formed within the marble, and during the Byzantium and Roman times we see many uses of marble for water transmission purposes, and we see still some artifacts being exhibited in the İSKİ Museum in Istanbul. 300 years after Christ were also the period when the Romans established the longest water transmission line in the world. It was 242 kilometers long, and that was the longest gallery of its type, and it was established in Istanbul for the first time in the world. And then, of course, the industrial age. Around 1500s, we see cast iron being used. Cast iron, of course, is something we're all familiar with. It's formed with graphite. It's an alloy. It used to be used for furnace covers as well. Cast iron is still in use in some parts of England. We know some transmission lines still consist of cast iron, but of course there are many problems with it. The last time I was in London, a large street was closed off because of a problem with the cast iron transmission line. 1455 in Germany, 1664 in France, 1885 in US were the years that cast iron was put into use for water transmission purposes in these countries respectively. Cast iron, of course, is difficult to cast, and it needed big furnaces. Copernic, at the time, 1500 was also the year when Copernic worked about the solar system. And in 1840s, concrete comes into the picture. It was very cheap material, but of course it was breakable, low strength. In certain water discharge facilities, we still see some concrete being used even in these years. Flat steel comes into the picture around 1880s. By molding or by pressing, the steel was shaped into pipes, and Mannesmann type steel pipes also came into the arena, and steel pipes are still quite significant, but now we also have spiral steel pipes, of course, used nowadays, and the first patents were taken in 1800s for steel pipes. Steel pipes, the spiral steel pipes, are thinner, but they are less resistant. And ribbed spiral steel pipes are very important nowadays. Mannesmann type steel pipes are used for uses where resistance to high temperature is required, but of course it's quite expensive. 1900s saw the emergence of steel-enforced concrete composites. This type of pipe was an advanced version of the previously used plain concrete. Of course, it's low cost. It has more than 50 years of lifetime. 1900s were also the years where we saw the emergence of serial production with the Ford Motor Company. Mass production came into our lives. 1930s saw the emergence of PVC plastic pipes. Polyvinyl chloride or chloride was invented by coincidence, and in 1941 550 tons of PVC pipes were manufactured. It's cheap, it's light, it's easy to use, it has a lifetime of more than 50 years as estimated by the manufacturers. Asbestos pipes are also quite light pipes. They are mostly used for water discharge or wastewater purposes in some countries still, but it is detrimental to human health. 1940s were also the years marked by the Second World War. 1950s saw the emergence of the plastic composite, the CTP. Now we're coming into Euro. Glass enforced plastics were used in Sweden and Switzerland for the first time, and CTP increasingly was manufactured in the 1980s for commercial purposes. Advantages in the features and the manufacturing flexibility meant a wide range of areas for use of CTP materials. 1950 was also the year of the DNA inventions. In 1960s we saw YYPE coming into use. It was the best alternative so far for transmission of water. In 1960s we saw YYPs coming into use, and from mid-1970s onwards for wastewater and drinking water purposes, YYPE was a material of choice. 1960s were also the years internet and fax machines came into our lives. 1970s onwards, we see DIP emerging. This was also again another coincidence during some military research. And this was ductile iron basically, with increased and enhanced resistance and durability. It is cast by way of centrifuge systems down to 6 millimeters. Lifetime is more than 100 years, and of course the soil quality is very important here. We also have some members of the global conglomerates in the room, and in 1970s the number of conglomerates in the world was 7,000. Can you hear me and see the screen okay? From the back? Okay. Fiber enhanced or enforced concrete emerged in 1980s. It's light, it's long, it's high resistance. Asbestos-free cellulose fibers are used for this material. Cellulose fiber and cement are mixed to produce this material. Lifetime is below 50 years. 1980s were the years we met mobile phones, and the 2000 onwards maybe you can't clearly read it out from the screen, but we see that there's a chart on the screen regarding the use of various materials in the United States and Europe. And there are some statistics with regards to what kind of materials are used in various countries. I would also like to say a few things about innovation and innovative products in the market. On-site manufacturing as a concept is innovative. Increasingly we see an effort to refrain from transportation of pipes. There's also a sub-area, dig-free technology. Digging, trenching were quite frequently seen in the past. There was a lot of dust and noise and whatnot, and the CTPs were brought in and installed 5 days, 10 days of disruption for traffic and the people living around. So this will be a thing of the past. Hopefully soon we will see an increasing popularity of dig-free technologies being used On-site manufactured pipes are transferred to the relevant road or street without any disruption to the flow of traffic. The dig-free technology is used. And there are also many innovations for coatings as well. Zinc coating is used, but it's highly, of course, corrosive. Now we have zinc, aluminum, or various polymeric coatings. We also have smart pipes, like I mentioned. The pipe is manufactured as in the form of U, the letter U. It has a certain thickness. By way of introducing warm air into the pipe, you shape the pipe by way of thermomechanic features to create new or other shapes, and PVC and polyethylene are the materials used for these purposes. These are smart pipes, as they're called. Maybe composite or CTP has similar efforts as well. Another innovative application is the following. The glass fiber and polyester are given the form of sort of a sock. It's very mendable, and you pull the two ends of it and you blow warm air into it. One side is closed, and from one side you blow in hot air, which means it takes the shape of the mold around it, and you cure by way of UV. This is called DCTP, cured in place. CTP pipes have many great uses. Nano additives and other additives are also quite important. For example, in certain composite products there is lamination. Water flows, and that fabric, that waved fabric material, leaves the parts, and laminated parts take place. To prevent this occurring, nano additives are used. Nano additives are used for polyesters. It creates a mechanical lock. This is also considered part of CTP per European standards. Do I have 5 more minutes? Let's talk about alternative pipe materials for exhausts or water coming out from an exhaust pipe and a bird flying after it. It's very nice. It's very nice. It's taken from a commercial, but of course water will not come out of an exhaust pipe. It will be either carbon dioxide or lead or other toxic materials. For some reason it's water coming out of this exhaust pipe, as advertised by a car manufacturing company. And the question is, what would you like from technology? It would be an environment without carbon dioxide. So I wanted to make use of it. Well, I think we need to keep it up in the sense that the way forward, the future, is the future of composite materials. Like you see on the screen, starting from 10,000 years before Christ, all the way to 2015. Various materials have been used. Ceramical materials, glass, various composites, even in those times were in use. 1960s, in the post-war era, were the years of metal and alloys, and the metallurgical and material engineers work on this. Of course, metallurgy is not only about metals, it's also about various different metals, because ceramic is being used, composite materials, polymers are used. And after 2011, when we look at the chart in detail, we see that the human race's choice of materials are composed of metals and alloys, composites, by 25% each, 1/4 of the total picture each.
Yükselebilir.
Well, we can talk about 4 groups: ceramics and glass, composites, metals. And in the beginning, before Christ, in the early periods of humanity, they found the material and they used it as it was. There was no knowledge, no hydraulic, no other thing. So the way that we found those materials as the humanity are shown, represented here in light colors. But in the following years, for example, let's come all the way to 2010, we see colorful generations because it's colorful. It's colorful because it's related with techniques, it's related with chemistry. The coating, alloys, and all of those products are products of synthesis. So our era is an era of synthesis when the design is also in the foreground. For example, in Istanbul, when the first water canals were established, and also many other things. So these are details about the history of it, so I will skip them because we don't have time. But what we expect from such infrastructures, of course, is first of all resistance, strength. And when you do put pipes, for example, underground, you need to have them strong and resilient and resistant against corrosion, excessive corrosion in particular. So resistance against corrosion, long-lastingness, and also the leaking free structures, resistance against friction and natural disasters, earthquakes, and tolerating the pressure, deviance, and many others. We should provide these all when opting for pipes. And when it comes to alternative pipes materials, of course, the price is another aspect. For example, in the CTP, the density is below 2, and elasticity is low here. It's 1, maybe it has increased, and the service temperature is in between -5 and 140. Tensile strength is very reasonable, and the fragility toughness is much better compared to the other plastics. The needling effect, the impact effect, and also thermal conductivity is at good levels, in particular for the glass fibers. So the biggest competitive here is the steel pipe. Its strength and toughness is good, but its resistance against the corrosion is low. And it has a larger service temperature span. And I'll pass this ductile pipes, and probably we will share that with you afterwards, so I will skip. The concrete pipes, its strength is very low. There is almost no flexibility, so it's difficult. And the PVC, in PVC, there are some other arguments for drinking potable water usage. There were some concerns about health. And about CTP pipes, this is what I took from one of the product booklet. They are demanded to be long and be light in weight, and compared to metal, it's 1 to 4, and the surface is expected to be smoothless, and state-of-art technology is used in any kind of diameter. It can be manufactured in all sorts of diameters. And the results. The information based on concrete results and tests should be used. The toughness, strength, and thermal specifications, if these are taken into consideration, steel and CTP pipes are in the foreground. Where the pipes will be placed, all the features of the earth, the ground, and any other respective issues should be revised. And the other issue is related with recycling. There is a high awareness about recycling, and the ones who are in the composite industry should think about the recycling as well. And as a result, I can say that in the opting for the pipes, the tensile strength or toughness or many other issues are taken into account while opting for the pipes. And I would like to thank you.